Okay, today we're going to talk about graphing quadratics. So the graph of a quadratic function is called a parabola. There are three forms of the quadratic equation. This first one you should be familiar with. Remember, we call this standard form. These next two will be kind of new. This one is what we do when we complete the square, but it ends up giving us the vertex, so it's called vertex form. And this last one, sometimes they call it factored form, which it is, but it helps us with the intercepts or x-intercepts, so I'm going to call it intercept form. Okay, as we go through looking at some graphs, there's some key features we want to identify. So, if A, notice how there's A in all three equations, it's the coefficient you can think of the x squared term, is positive. Meaning if A is greater than 0, then the graph opens up. This is known as concave up, which means your graph looks something like that. Remember, our parabola is U-shaped when it's facing going up. Whereas if A is negative, meaning A is less than 0, then the graph opens down. And this is known as concave down. Okay, all quadratics have a vertex. And this vertex is either a minimum if it's concave up or a maximum if it's concave down, and it's the turning point of the graph. All quadratics graphs are symmetrical across what we call the axis of symmetry, which runs through the vertex. Specifically, it runs through the x value of your vertex. In general, the formula, if we have it in standard form, is think about your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's that negative b over 2a. That's where we're starting at, and then we add or subtract a value from there. Okay, a quadratic function crosses the y-axis. Once again, if we're in standard form, at the c value. Okay, and that's definitely the easiest one to find the y-intercept, although you can find it in any of the equations. And your y-intercept always has an x value of 0. So for parabola, the y-intercept will always be the point 0. And then in this case, it's comma c. And these two cases, you'll have to plug it in and find out that number. It's not given to you in the exact form it has. Okay, and then remember, a quadratic function crosses the x-axis 0, 1, or 2 times, right? Based on if it has 2 imaginary, 1 real, or 2 real solutions. So let's go ahead and take a look at this graph. So the vertex is that turning point. So notice here you've got a maximum. This is your vertex. And that maximum point is the ordered pair 1, 4. Your axis of symmetry is where I can fold the graph in half and it will land on each other. So it goes right through your vertex, and it is going to always be a vertical line. So in this case, it is the line x equals 1. Your y-intercept is where your graph crosses the y-axis, which here is at the ordered pair 0, 3. And this x-intercept has 2 places where it crosses the x-axis, negative 1 and 3. So you can think of that as the 2 ordered pairs negative 1, 0, and 3, 0. As for concavity, this is opening down. Okay, the first form we're going to look at today is standard form. Standard form is the one that we're probably most familiar with, and the big thing about standard form is it tells you the y-intercept. That c value is your y-intercept. So, to graph this function, f of x equals 4x squared minus 8x plus 1, the first thing we'll do is find our axis of symmetry. That axis of symmetry, remember that formula is negative b over 2a. In this case, our b is negative 8, so when I take the opposite of negative 8, I get positive 8, all divided by 2 times a is 4, so I'm getting 8 divided by 8, so x is 1. So, in order to find the vertex, plug x back into the equation. So we're going to go ahead and plug 1 in here, which is our x. So we're saying 4 times 1 squared minus 8 times 1 plus 1. So 4 minus 8 is negative 4 plus 1 is negative 3. That means, hey, my vertex is at the ordered pair 1, -3. And I like sometimes as I go along to kind of grasp some of these things. It's also saying, hey, my axis of symmetry here at x equals 1 is where it's going to be reflecting across. So as we're going through the key features, you may want to just identify, hey, A is 4, B is -8, and C is 1. Since A is positive, it's going to open up. If it opens up, that means there's a minimum value, so this should be the lowest point of my graph. And your axis of symmetry we found is at x equals 1. Our vertex was at 1, -3. And then our y-intercept, remember that's our C value. So if you plug 0 in, notice how that would be 0, this would be 0, so we really just have that +1. So our y-intercept is at 0, 1. Might as well graph that point. And then we want to find at least one other point. So the one other point that's really easy is, remember this is an axis of symmetry, so whatever happens on the left side should happen on the right as well. So the point 2, 1 should also exist in my graph. You may want to pick just one other point close by, so maybe like 3. If I plug 3 into my equation, then I'm going to have 4 times 3 squared minus 8 times 3 plus 1, and I get 13. Notice that even is off the graph, so we'll know that in -1, 13 is also off the graph, that this will be really steep on this side, and then it comes down and makes that U shape. Okay, what I'd like you to do is go ahead and do the U-try. Next, we're going to talk about vertex form. So as you can probably tell, it's going to tell us the vertex. Notice it says the vertex is always the value of h, k. And be careful here because notice it's x minus h. Okay, so as we go through, let's look at these equations. Okay, so here our vertex, x minus 2, so that means h is 2. And then we're adding 4, so 2, 4 is my vertex. And A is positive 2, that would tell us my graph is opening concave up, right? Here, be careful, x plus 3 really is the same thing, x minus a -3. So my h value is -3, my k value is -5 for my vertex. Here, A is -4, so remember that will tell you, hey, it's concave down. For this last one, we do have the -1, so we know our vertex, our h is 1. The y value of our vertex, our k, is -2. And A in this case is just that negative, and so we usually put a 1 with it. Remember, that is telling us it's concave down. So as we go to graph this function, let's first go ahead. It is in, notice first it's in vertex form. Our A value is 2. So that tells us it's concave up. If we've got something that's concave up, that means we have a minimum, a low point. Our axis of symmetry, first of all, look here. What's our vertex? Well, our x value of our vertex is 3, right? And then -4 for the y value. Since our x value is 3 of our vertex, that's going to be your axis of symmetry. So when I plot the point 3, -4, we're saying, hey, through this line right here, that's where the parabola should be reflecting across. For your y-intercept, if you plug 0 into your equation, then you'll be able to find out the y value. So we're saying, what's 2 times -3 squared minus 4? -3 squared is 9, times 2 is 18, minus 4 is 14. So that y-intercept we won't be able to graph, but we know what it is. But then we want to find at least like one other point. I would choose something near this vertex, so maybe I plug in 2. So you get 2, and then 2 minus 3 is a -1 squared minus 4. So that's 2 minus 4 is -2. And notice this time, if you have it on the left side, we know that also exists that same point on the right side. If you feel more comfortable, you can also plug in 1. If we plug in 1, then we get the point 4, and we could reflect that on the other side. And I would say you want a minimum of 3 points, but having 5 points is probably a little bit more accurate to make your parabola. So I didn't quite go to the bottom. Something to point out, I had done this wrong earlier, and I had put the vertex at 3 positive 4, forgetting that it was a negative there. Something there, when you would have done it, you would have realized that that goes down, and all of a sudden your graph would have been looking concave down rather than up. So that's a good way to double check your work that you're doing things correctly. Okay, you go ahead and do the U-try. Okay, last but not least, we've got factored form. So as you can tell, it is factored. And remember when we said, hey, we're solving these, we're saying P and Q are the x-intercepts, just like when we solved in our last unit. They are also known, think about your rocks. Your x-intercepts are also known as, I'm going to put roots here, but I could also call them zeros, right? They're also known as solutions. All those things are the same. Here, as you think about this is like a more logical way rather than just memorizing an equation. When you've got a graph here, your vertex, let's say this is where it crosses the x-axis. Your vertex will always be halfway between the two x-intercepts. Okay, it's always going to be exactly in the middle of them. So that's why it's saying, hey, take P and Q, add them together and divide by 2. That's the midpoint, or halfway between those two. So as you look at this first one, when you think about your x-intercepts, think about when we solved this. When we said x minus 1 equals 0, for example, which is the case when we're finding an x-intercept, we said x is 1. So the point 1, 0 is our x-intercept. Whereas here, we're not going to just say 2. We're saying negative 2 plus 2 gives me 0. So negative 2 is the other x-intercept. So if you think about your axis of symmetry, we're saying x equals 1 plus a negative 2 divided by 2, halfway between 1 and negative 2. Well, that gives you just simply negative a half. Okay, here, notice negative 3 is the x-intercept, and that negative 3 there is the x-intercept. So really, this is one of those cases where there's one solution. Negative 3 happens twice. So what's halfway between negative 3 and negative 3? Well, that's just x is negative 3, which makes sense because this graph will just touch the x-axis at negative 3, 1. So it looks something like that. Okay, last but not least, we've got over here, we got x minus 7, so that means your x-intercept is 7. And we got x plus 1, so x is negative 1 comma 0 for your two x-intercepts. For your axis of symmetry, we're halfway between, x is halfway between 1, 7, and negative 1. Divided by 2, and we do that, we get x is equal to 3. Okay, let's try an application as we're going to go ahead and graph this quadratic. So a here is negative 2. Since it's negative, this time our graph is opening down, which means our vertex is either going to be this time, rather than being a minimum, is going to be maximum. Okay, I'm going to go down here to x-intercepts and then come back up to your axis of symmetry. So our x-intercepts are 3, 0, and 2, 0. So if I want to talk about the axis of symmetry, it's that 3 plus 2 divided by 2. So in this case, it's like 2.5, or if you prefer, you can do 5 halves. So if I put 5 halves into 5 halves or 2.5 into my equation, I end up with 0.5 as that vertex. So we're saying, hey, 2.5 and 0.5, this is going to be the high point, and everything in my graph is being reflected across this line, which makes sense because if you look at 2 and 3, that's the exact mirror image, and that vertex is halfway between it. Now for your y-intercept, you're saying plug in 0 into your equation. Well, that gives me negative 2 times negative 3 times negative 2. That ends up at negative 12, so that's going to be off my graph. So let's choose another point, maybe something between 0 and 2. So 1's an easy point to plug in. If I plug in 1, then I end up with negative 4. And that's a good point to use on both these sides. Okay, I would like you to do the U-try. Just some side notes as you're thinking about it, as you get into it. Yeah, you do know how to go ahead and hit y equals and plug in an equation here to double check if it's correct. I do want you to understand what's happening versus just plugging it in mindlessly and copying it. So I think this is a great way to double check your work, but I would like to see your thinking behind how you got that graph.